Section 10.3 brings us back to trigonometry and polar coordinates. Polar coordinates are ordered pairs. They are points represented by the radius and the angle. We start off with the polar axis here. Kind of looks like the positive x-axis. And then we measure our point by taking the radius r and then rotating counterclockwise through theta radians. So we have this point r theta. It's r away from the origin or the pole, and its angle is theta. If we take r and make it negative, that flips us across the pole, and I guess you could say it adds an angle of pi to our angle. So here we have negative r theta. Now that would be the same point as finding angle r, radius r with angle negative theta. So you see that there are many different ways to draw the same point in polar coordinates. And of course you can make loops by taking multiples of 2 pi, and that would loop us around by one full rotation. A couple of formulas that we need to remember when dealing with converting from polar to rectangular and rectangular to polar. X equals r cosine theta, y equals r sine theta, the Pythagorean theorem, and then the tangent of theta equals the y over the x. And if you want, you can rearrange this to say theta is equal to the arctan of y over x. So an example is to change this rectangular coordinates 1, negative 1 to polar coordinates. So here we have our x, y axis, and then on top of that here is our polar axis in blue. So you can imagine there's a radius 1, there's radius 2, and so on. So I know that x equals 1, y equals negative 1, and we need to find the radius and the theta. So we're going to use the second line of our formula, the Pythagorean theorem and the tangent. And r squared is equal to 1 squared plus negative 1 squared. R squared equals 2. R is equal to the square root of 2. Now we don't need plus or minus here in this problem, and I'll show you why in a second. For theta, we have the arctan of 1, negative 1 over 1. The arctan of negative 1 over 1, if you use your calculator or if you remember your unit circle, you'll notice that this theta is negative pi over 4. So we have a couple ways to think about this point. We can think about it as a radius of square root of 2 and an angle of negative pi over 4. We could also think of it as a radius of negative square root of 2 and an angle of what? 3 pi over 4. So we would move through the angle of 3 pi over 4. That puts us in the second quadrant. And then we would flip across because of the negative radius there. The easiest angle and radius to think about is just the standard square root of 2 and negative pi over 4. Don't forget the domain and range for arctan. Arctan will only give you solutions in the first and the fourth quadrants, so be careful. Make sure that your point is the one that you want it to be.